Hello everyone. Thank you for being here today. So today I want to present a basic course on CosmWasm. It will be really starting from the basics. So simple contract, and then we will upload it on Neutron testnet and try to interact with it. And I think it's quite useful for the people that are new to CosmWasm, especially if you are planning to participate to the hackathon. Okay, so brief introduction about myself. I am a blockchain developer at Confio, where among other things we build and develop CosmWasm. If someone of you wants to follow along with me, you can scan this QR code or go to this link, and there is all the commands that you can copy paste and set up your environment and everything. So everyone ready? Okay. So this is the repository where I have like basically all you need to follow along with me in this workshop. So is there anyone that wants to follow along? Okay, 1, 2, great, 3, 4, 5, great, really happy. Okay, so first thing is to set up the environment. It might take a while with the internet connection, so we'll wait a couple of minutes, and then if you have Rust already installed, we could probably proceed. So yeah, like the main thing for the contract is to install Rust. Then we add the wasm target with this command so that we can compile the contract in WebAssembly. And then we install this command cargo generate to generate the actual boilerplate contract. Okay, so I have this already installed, so I will start process. So I run this command. Nice. Okay, so I set the project name, contract, and then set minimal to true. So we have a minimal boilerplate where with basically the skeleton of the contract. So here, let's say the most important files that we will consider in this workshop is lib.rs, message.rs, and contract.rs. So first of all, a CosmWasm contract is basically a Rust library compiled in WASM. So each Rust library has an entry point, the lib.rs file, and this is kept to declare the modules that are included in this library. That's why it's kept quite simple and clean. And here, for example, we include all the modules are basically the other files that you see in the folder. Then we have the message.rs. Here, as you can see, there are some empty structs and enums. These are, in this file, we will declare the message structures that we will need to interact with the contract. And then we have the contract.rs, where we need to, basically, that contains all the logic of our contract. Okay, so, by the way, if you have any question, just stop me anytime, ask questions. Let's keep it interactive, okay? Okay, so I will just copy paste the content of the message.rs file that I have prepared with all the messages that I have prepared. Yeah. Oh yeah, sorry. Oh, wait, like this. Oh yeah.
Because you're talking about your high.
Okay, yeah, sorry.
Check the recording.
Okay. Yeah, but maybe.
Here I can see this.
Yeah.
I know, but.
Okay. Okay, so. Okay. Okay. Okay, so I don't know why it's not. One second. Okay. I hope the noise stops complaining about the. Anyway, so basically for our counter contract is really simple. It's gonna be just a contract that you can instantiate, and so the instantiation is basically as a constructor. So you can set up the initial value that we can set up it to 0 with this message, or we can set it to a value. And then then we have the execute messages that are basically the messages with which we can perform an action on the contract. So we can increase the value by 1, decrease the value, or set it to a different value. And then we have the query message that basically is we perform the action to query the value of the counter from the storage. And see what is the result. Okay. Now we go to the implementation of the contract entry points. So, and with this, it's going to be more clear why we need these messages and everything. So, I just want to, I don't know why it's complaining about. Okay. Sorry, I don't know why it's complaining about this. Anyway, so our contract logic looks like this. So we have some imports where we import all the utility functions that we need from the, for example, from the CosmWasm standard libraries, and then we import all the messages that we have already declared in the message.rs file. And here is, let's say, the most important part of the contract, so the entry points. What are the entry points? Basically, a simple Rust contract that you're used to work with has usually one entry point, is the main function. So when you run the program, the operating system will trigger the main entry point, so the main function. The contract has instead multiple entry points, and those are, for example, instantiate, execute, query, migrate, and sudo. So for the scope of this workshop, we'll just go through instantiate, query, and execute. Let's start with the instantiate. Okay. So the function has this signature that where we basically have depth mute that is basically the parameters that allows us to access the part that is external to the contract. So from this one we can access, the contract can access the blockchain storage, can communicate with other contracts, and basically everything that is outside the contract itself. And we have is mutable because the instantiate is actually an entry point that can mutate the state of the storage, so the state of the contract. So and that's why is actually the constructor. So for example, in this case, we define this counter as an item in the storage, and then with the instantiate entry point, we say, okay, if using this match statement, we say, okay, if we receive a message that is 0, then set the state of the contract to 0. Otherwise, set it to the value that is passed. Then, in the same way, basically, is the execute entry point. So also here, execute is an entry point that can modify the state of the contract. And here we have the three messages that we defined before. So we have inc, dec, and set. And basically, using this match statement, we can define which action to perform on the state. So we think we take the old value and increase it by 1, or we decrease by 1, or we set it to a new value. I forgot actually to talk about the other parameters that are basically the same in instantiate and execute. And so I talked just about depth mute, but we have also env, that is basically the blockchain state. So as you can see, it's a simple structure that has block info, so the block height, the transaction, and the contract info, like for example the contract address. And then we have the message info, from which we can retrieve, for example, the sender and the native tokens from which the message was sent. And then we have the execute message, that is the ones that we defined before. And then the last one is the query entry point. This is different from the one we saw before, because the query entry point cannot modify the state. So as you can see here, we don't have in the parameters we only have depth, not depth mute, because this entry point cannot modify the state. And also we don't have the message info parameter, because the query entry point doesn't have to care who is sending the message or the native token, because not performing any state changing action, it doesn't have to pay any fee or anything. So, and what we do here is just basically we read from the counter. We read from the counter and we say, okay, just return the value. Okay, no. Okay, how to build the contract? So you have two possibilities. One is for local testing. So if you run your local chain and you want to test it and interact with it locally, you can just run this command. And okay, and we are going to see the artifact inside um, target WASM and release. Okay, so here we can see that this is the artifact generated, and this is the actual contract that we can upload to our local chain or to the actual testnet or mainnet. But as you can see, this is quite big. So usually for testnet and mainnet, we run the optimizer that basically cuts the size by almost 10 times. So now we are going to upload this contract on Neutron testnet. I will run the optimizer. So here you will find the command to run it. Okay, so now our contract, our artifacts is going to be in the artifacts folder, and as you can see, this is more or less 10 times smaller than this one. And this is going to be the one that we upload now on the chain. Yeah, before doing that, last thing, we can actually check before uploading a contract. We can check if it's a valid contract and what are the capabilities required by our contract. What are the capabilities? So, sorry. So basically, capabilities are built-in functionalities that we have in CosmWasm, and chains can decide to have them or not, and which one to have, and they're basically features. Like for example, iterator will allow to iterate through the storage. Stargate will enable basically IBC messages. Then staking is useful if you use the staking module, the Cosmos SDK staking module, and then we have others, and here you will find all the documentation. So we can run basically this command to check what are first of all, if the contract is valid and ready to be uploaded, and what are the capabilities. Okay. Oh, sorry. Okay. Okay. There is something wrong with the contract. Nice. Okay. There is something wrong. So I will quickly check what is wrong with this. So, sorry. Okay, there is some error here. I will try to just run again the full thing. There is some dependency error, and I will just do one thing. I will just No, there is some problem with the. Yeah, maybe I can ask the help from Simon. Simon, here there is some error here in Rust. How do I do this?
Live debugging.
You can't see actually. Can you see that?
Yeah, I can see that, but I have no idea. It looks like something. It's Rust Analyzer. That's just the IDE.
Okay, it's just the ID. Yeah, but actually when I build it, it complains. So. Okay. Okay, I will try again to run the command. Okay. Sorry, not this one. This one. Okay. Okay. And now artifacts. And now let's check if this one is valid. No. Did okay, then it's just okay. Then okay. Cosmon check counter. Okay, there is then a typo here somewhere. Okay. Anyway, now it passes and everything is good. You will find the solutions branch on my on the repo. So, okay, we can continue. So now we have the basically optimized version of the contract. So again, let's see the size. Yeah, is 10 times smaller than the one in the target folder, and now we can start uploading it on Neutron testnet. So to do so, what you need to do is to first set up a client on your machine. To do so, you need to clone the Neutron repo. Check out version 5.0.2. That is the actual version of the network, the testnet network, and then you run make install. After that, you should have when you run Neutron D version, you should see it working, and it should look like this. Okay, so something like it should look like this. So. Okay.
Whenever you run the command, it tells me that I need go 1.22.
Yeah, you need go 1.22, which is your.
Higher doesn't work?
No, it doesn't work, unfortunately. Yeah, so you will basically need to remove the old version and install the new one. Yeah. So yeah, just to answer also to your question, usually to test your contract, you have some utilities. So there is this library called multitest that allows you to test and basically mock the blockchain environment and make sure that you can mock the environment and then instantiate, store, and execute messages in Rust. And you don't need to do all this starting a blockchain or uploading it to a blockchain. This is more like showing end-to-end how it will work. Basically mostly also for the sake of the hackathon, where you probably are going to use maybe some functionality from Neutron and you will need to interact with the actual chain. So yeah, so once you have the Neutron client set up, you need to configure the value for the testnet. So the chain ID, keyring backend, and the actual RPC node to which your client will connect to. Once you've done that, you can then add a new key. In this case, I picked the name CW Wallet, and then you need to visit the Neutron Discord server, and I will show you. So here, basically, you will find under the general section, you will find this testnet faucet, and when you run the command like $request and then the key, the address generated when you add your key, you will receive 2 Neutron testnet tokens that then you can use to upload and interact with the chain. So in my case, I have it already. So yeah. It doesn't check out.
In my case.
Okay. Can I will check really quick.
Check out solutions.
Right. Okay. So I have already actually generated my key, and I have already the tokens on my address. Yeah.
What, does it have to be 122.0 or any works? The Go version.
No, and I think any works. Any works.
1.22.
Yeah.
Whatever.
Yeah, it's gonna work, I think. So once you generate your key, you will have this address, and this is the address that you will need to copy paste in the request when you do the request on Neutron. And then if you first of all, you can do this only once every 24 hours, and then when you can check also your balance. So let's see if okay. So for example, here I have done it a couple of times, so now I have like 4 neutrons basically. Okay. Okay, so we are in the artifacts folder, and we have the address with some tokens. We can upload basically our contract to the chain. Okay. So now, first of all, we have to see if that transaction succeeded. You might get some errors here, but these gas and grass price parameters should be good for this contract. Otherwise, you need to twist them a bit. But now I can query the transaction to see. Sorry. Okay. Query the transaction to see if in the events I can find the actual code ID that is basically the unique ID that references my binary on the chain. So if you check the events, scroll, at some point you're gonna see, okay, this event is store code, and this is the code checksum, and this is actual our code ID. And we'll need this information to then be able to instantiate. So our code is now basically just upload there, but there is not an instance of the contract, there is not an address. It's just a binary uploaded and referenced by a code ID. So now we will instantiate it. So the code ID of my contract is 8436, and just a few. Okay, and I can just now with this command I can just instantiate it. Sorry. Okay. So here there is this code ID parameter. So the command, the instantiate command, takes as input. Okay, first of all the the usual flags like from the sender, and the admin that is basically the address that can perform some special operation like migration, a label to basically have some human readable label for the contract and so on. But the most important ones are they are all actually related to what we have done. Is the code ID. So in my case is 8436, and this is the actual message that we want to pass. So in this case, for example, I want to pass the 0. So, and what 0 does is basically it basically sets the counter to 0. I can try to, I could pass set and set the value to something else, but if I put something that is not in the one of the enum variants, so that is not one of these two, then it's gonna fail. It's not gonna accept the instantiation. So now I will start this, and I will expect basically the contract to be instantiated and to have basically state as a state the state of the counter to be 0. So I will query again the transaction, because from the events we can find out what is the contract address, and we can use then the address to perform the actions like increase the value, decrease the value, query what is the actual state. So okay, so from the events I'm gonna find the instantiate event, and okay, instantiate event, and in the attributes I can see the code ID, that is the one that I have used, and the contract address. This is the contract that the address that I have to send my all the actions, all the messages that I want to perform on it. So first of all, I will try now to query the state. So there are, I will go here actually, so you can. So here I made an overview of what are the actually queries that are possible in CosmWasm. So we have query all. So this one will basically, it will not even pass through the contract. It just queries the state directly of the returns just the state of the contract, the storage of the contract. So the storage is just basically a key value storage, and we can try this, but is mostly used for debugging, but is not really useful for others. So now I will just query the storage for this contract, and I will, sorry. Okay. I'm actually gonna write my contract address here so that it's easy to then copy paste it around. Okay, so okay. So I run this query, and this is gonna return the storage of the contract. So the storage of the contract looks like this. So there is a list of models, and they are referenced by a key and then a value. And basically, if you know the key of the let's say of the state that you are interested in, you can also use this raw query that is very similar to the all, and it will basically so it will basically return the base 64 encoded state for this key. Okay, and if now I decode this, I can see that it's actually 0. But yeah, this is more used for debugging, and is not what actually we did in our contract. So in our contract, we created this sort of API. So we have our entry point query that has an actual query that will return the value of the counter. So we are going to use this so-called smart query to query the value of the contract. And here I have the command. So as we did, so just to see the difference, these two are not passing through the contract to fetch the state, but this is. So this is the one that usually is used. This is a sort of API. And now I'm going to use this one to query. Okay. Okay. So I will send this query message to the contract, and I expect exactly the value of the counter is 0. Now we can take a look at how to execute a message on the contract. So here we have 3 different ones. So as in our API, so increment, decrement, and set a value. We can try, for example, to increment it, and here we have to set the gas, and because we need to pay something as we are executing an operation that is going to change the state of the contract. So I will copy paste this, but I will do it here so that I can basically set the contract address in here. Okay. 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 So according to the logic that of our implementation, this inc message is gonna increase the value of the counter by 1. So now if I query the value, yeah, the value is 1. If I run it again, okay, I will expect that the value is true. Let's wait a couple of seconds so it's included. The transaction is included in the block, but okay. Yeah, so now the value is true. And we can do the same thing with decrement or set the value to any number. in the range. What else? Yeah, here I have added actually two references. One is this Neutron Nebular workshop that is one from 2023, where there is a more advanced, so it does some interaction with the ICQ and ICA, and is like neutron-related workshop. And I suggest to look at it for especially for the people that are participating into the hackathon. And then a link to the CosmWasm documentation where you will find basically the same contract. And for example, you will see that part that is multi-test that is not covered in this workshop, and will basically explain how to test your contract directly into Rust, actually in the same file where you write the logic. So much simpler and less problematic. I don't know if someone has any questions.
I wanted to ask about the Neutron D utility. Is it something that was forked and just adjusted, or like every chain on Cosmos has to build something like that from scratch?
Yeah, so basically, Neutron, as many others, is a Cosmos SDK-based chain, and basically they work more or less all the same. So basically, the code is both used for, let's say, for the client and for the server. So when you install this Neutron, you're going to have this Neutron D CLI that you can use it to, for example, start a node, or you can also use it to query, execute commands, and so on. And so, for example, I don't know, if you try, for example, WasmD, so you check the repo of the module of CosmWasm, there is the same. So you can do, for example, make install. After it's installed, you can run your node, or if you have a node running, you can query it through WasmD query, and so on. Yeah. Okay, to access this from the front end, I think you need to use like something like CosmJS, but I'm not an expert on this, and I think you will find some front end tutorial even on Neutron. Any other question? Okay, and just another thing that I just wanted to tell you, I don't remember I didn't tell me the name, but sorry, one thing about the front end, I want to tell you that of course you can use always the RPC endpoint as an API and send from there query the things, but I think the way that is done is by using some front-end libraries, like as you said, CosmJS, but you should check the cosmology repos, and they have all these front-end utilities to get you up and running really quickly on the front end. So I already built all these utilities for Cosmos SDK based chains. Okay. Yeah. Any other question? Okay. If not, then thank you. And these are, if. Okay. Yeah. Okay. Yeah. So thank you. And these are, my contacts. So if you have any questions, even during the hackathon, or you want, just send me a message. And and about the workshop, I tested it multiple times. It should work. As Simon said, it's probably some IDE issue, the one that I had. But if you find some bug, just feel free to open a PR, and I will solve it, or we can comment it in there. Okay, thank you very much.